Hi everyone, this is Om Godge and today we'll be solving lab. What lab is this? Lab 8. Okay. Yeah, we'll be solving lab 8. Alright, so the first question was transpose. You are just given the matrix in this and you have to take a transpose of the matrix. So if you have 1, 2, 3, 4, you have to print 1, 3, 2, 4. Yep, that's all. What else is given? Okay, fine. So I've used vectors in my solution. Okay, let's say you have this matrix uh, which has n columns and m rows. Right, I think that's what's given in the question. N is the number of time slots and m. Okay, fine. It's the other way. My bad. So this is m and this is n. So when you take a 2D vector or a 2D array as input, you iterate over all the rows, then you iterate over all the columns and fill these one by one. So you fill them this way, like you fill one row at a time, right? So yeah, so you will fill this one first, then this one, then this one, then this one, this one, this one, this one, so on. Then you will fill this whole thing and you will move on to the next row over here. So if you want to take the transpose of this, one simple thing that you can do is um, instead of starting with the rows, just start with the columns. Start with the columns first, then go with the rows. So you will start filling them this way, like column by column. Then the first element will become here, the second element will come here, the third element will come here, and so on. And you will get the transpose of the matrix. Also, you have to modify these. So this will be n now, and this will be m. Okay, and then you get the transpose of the matrix. So that's how you get the transpose. So that is what I've done in my code. I have n and m and I take them as input. Then I create uh, a matrix with m rows and n columns, which is the transpose, which has the transpose of the original matrix. Fine. And then I do cn mat ji. So j is the inner guy, I is the outer guy, and I do cn mat ji. This will make sure that you fill every column first. You're filling the columns first, and then you will fill so you'll fill it column wise basically, as I said here, and then you just print out the matrix. The print function is simple. You just have two for loops. So the first for loop iterates over each row, the second for loop iterates over each element, and you print the element and a space after it, and then you just print a new line after each row. Okay, I'll just show it working. Okay, fine. That was it for this question. Okay. Now for the next question, two-player game. You are given one sec. Okay. Okay, there are two players and you are given one array and you have to pick out numbers from either side of the array, and you have to return player one's maximum score. So let's say this is the array that you have, and is there an example given? Okay, let's pick this example. So you have this here. I'll make this smaller. Now you can choose to select either this one or this number, because you're the first player. So the first player can either select 1 or 7. If the player 1 selects 7, then the player 2 can select 233 and he will win. So 7 is not a good move, 1 would be a better move. So player 1 would then select 1 over here. Then player 2, so 1 is gone. Now now player 2 has either the option of selecting 5 or 7. Now whatever player 2 selects, player 1 will get 233 for free, because it will if you select 5, then you'll get 233 and 7, and if you select 7, then you'll get 5 and 233. So in either case, player 1 will get 233. So then player 2 will choose to select 7 because 7 is bigger than 5, and then player 1 will select 233, player 2 will select 5, and then player 1 gets the max score of 234. So yeah, that's what this question means. Now to solve this question, okay, so to solve this question, you have an array. Let's say now right now it's currently P1's turn. Okay, so player 1 is going to play. Now what player 1 can do is select either this guy or this guy. He can either select the first element or the last element. So if he selects the first element, then you're left with the rest n minus 1 elements, and now player 2 will play over here. Fine. So this is a recursive case. So player 2 playing over here is the same as player 1 playing over here in a way, right? And similarly, if you have if player 1 selects this guy, the last element here, then you're left with the first n minus 1 elements, and on this P2 will play. Now P2 selects from here. So this is another recursive case that you have, is solving the max score for P2 starting from P2 for n minus 1 elements. Yeah, that is a recursive case that you need to solve for. Fine. And then the base case would be when you have so the length of this array is going lower and lower, right? Now you have n minus 1 elements, so at some point you will be left with just one element, so that will be the base case of your recursion. Let me show you the code so that you understand it better. Yeah, I think this is enough. Let me just confirm if this works. Oops. Okay, fine. So okay, you have an integer n, you take it as input, you have a vector to store all these numbers, you take them as input, and then you call a get score function. So this get score function takes 4 things. Okay. So your get score has a vector. A vector passes a reference of nums. The reason why you pass it as reference is because this vector can be big. It can be really large, and when you do recursion, you don't want to copy this vector unnecessarily. It will be better if you can use the same vector over and over without copying it and making a new copy of the same array or the same vector. That is why you pass it by reference here. Fine. Then you have L and R. So L and R denote oops. Um, L and R denote the starting and the ending points in the array. So this could be L and this could be R over here. So it just means that you are basically looking at this particular sub array for now. These elements are taken by some player, right? And then uh, the last thing is a boolean for storing which player is going to play. So is P1 stores whether it is P1's turn or whether it is P2's turn. If is P1 is true, then it is P1's turn. Otherwise, it's P2's turn. This is the function that you will call, and this will return. This function returns P1 score. Okay, it returns P1 score. It doesn't return P2 score. Fine. Now let's understand what this function does internally. Okay. So the first is a base case. If there's only one element and it's P1's turn, then you return that element. Otherwise, P2 will select it, and so P1 score stays the same. So return 0. Okay. So the base case is L equals R, which means only one element in the array. So if there's only one element and if it's P1's turn, so as I explained over here, if it is P1's turn, then P1 will select that one element and it will get the whole score. Otherwise, P2 selects that element and P1 gets nothing. He gets 0. Fine, this is the base case. Then you have the recursive case over here. So if it's P1's turn, and then this is otherwise if it's P2's turn. Okay, and that's why I passed a 1 over here, because it is written that P1 starts the game, like P1 is the first player to play. That's why I've passed 1 over here, which is the same as putting true, like the first move is P1's move. That's why this is 1. Okay. Let's look at this this case first. So I've written max of nums L. Let's start from understanding nums L plus get score nums L plus 1 R not is P1. What does this mean? Okay. I'll keep this over here. Okay. So this just means that if you had L over here So L was this element. All of these elements are gone. You don't need to consider them. Fine. So this just means that P1 selected this element. So that's why this is getting added into P1 score. Nums L is selected by P1. That's why this is added into P1 score. And then you say, well, just check, get the score for L plus 1 to R. Like the remaining part, get the score for that. And now it is P2's turn. So P1 has played now. The next person to play is P2. That is why I've done not is P1. Not is P1 because currently P1 is P1 will be true, not is P1 will be false. You can actually just write 0 over here if you want, or write false over here, because you have checked this condition here that P1 is true. So you can do that, but I have just written not is P1 over here for now. So this just does, this just tells you that the next move that will be played by the other player. Like whoever played this move, the other player is going to play the next move now, and you'll get this maximum score from L plus 1 to R, and then you add it into nums L, and that will be the score for P1. Okay. Alright. This is when you select nums L. Now similarly, what if you select nums R? So then you will have this over here. I'll just put this here. So all this is gone, and now you have R over here, and you select R now. Now that you selected R, all this is gone. This is not there. Oops. So now that you oops. One sec. I added too many dots there. Okay. If you have selected R, so now you want to find the score for L to R minus 1. And then again, since P1 played now, so the next move will be played by P2. So you call get score on num from L to R minus 1. I think this should be clear. So you want to maximize the score that you get from both of these cases, like either from P1 selects R or P1 selects L. You want the maximum score from both of these cases, and that is why I've put a max function here. So this whole line, this whole line is just select the choice which gives the I'll just start here. P1 has two choices, either to select nums L or to select nums R. P1 selects the one which gives him the max score at the end. Hence, we use recursion to find out selecting which one would provide a bigger score for P1. Okay, so you have this case, which is like P1 selects the score that P1 will have if he selects L, and this is the score that P1 will have when he selects R, and you take the maximum of both of those, and that you return that as the answer. That is what's written here. Okay, now if it is P2's turn, if it's P2's turn, P2 will try to minimize P1 score. Fine. Okay, I'll put this over here. I think this is required. This can be removed. Yeah, I think I'll keep this. Okay. So currently this um, this is L and this is R, and now it is. I'll just move this below. Now it is P2's turn to play. So how does P2? How will P2 return get score? So since the get score function, it returns the score for P1. So what P2 tries to do is minimize P1 score, ultimately maximizing his own. Right, so that is why. So okay, so if he calculates get score for nums L plus 1 R and not as P1, this gives the score of P1 when P2 selects nums L. Okay, if alright, uh, oops. So if P2 selects nums L, then you will have this range from L plus 1 to R, and calling this function will give you the score of P1 when P2 has selected this. Fine. Similarly, I'll just copy this line. This will give you the score of P1 when P2 selects nums of R. So L to R minus 1 will be there when P2 selects this guy over here, and this rest of the thing is available for P1. So then this will give you the score of P1 when P2 selects nums of R. Now P2 tries to minimize to play that move which will minimize P1 score. That is why you have a min over here. So you have a min get score nums L plus 1 R, which is the score of P1 when P2 selects nums L, and this is the score of P1 when P2 selects nums R, and you take the minimum of both of those and you return that as the score. Hence returns the min score on selecting either of the numbers. And then yeah, that's the whole question. Yeah, that solves everything. Okay. The next question is climbing stairs. So you have to climb n stairs, and you can only climb 1, 2 or 3 stairs at a time. So you need to find the number of ways that you can climb all of them. That you can climb n stairs, like the number of ways within which you can climb them. Okay. Okay, so even this question has to be solved recursively. So the base cases, let's start with the base cases first. So the base cases would be n equals 1, n equals 2, and n equals 3. The reason, okay, I think I should start off with the recursive solution first. So I'll just write a recursive equation. So num stairs, I mean cos ways of n. So the possible ways of climbing n stairs. This is what pos ways is. Okay, so cos ways n will be equal to cos ways n minus 1. This is when I should use this instead. This is when one stair was climbed. Okay, when you climb one stair, you'll have this plus cos ways n minus 2. I think I should shrink this. Plus cos ways n minus 3. Oof. This is when 2 stairs were climbed, and finally this. Why doesn't this not get selected? This is when 3 stairs were climbed. So this will give you cos ways of n. So to understand this better, I guess I could try drawing a diagram. Let's see. Okay, these are steps. I don't know if this is good enough diagram. Okay, just try understanding this once. If you have to climb n stairs, the first step that you will take, the first step can be taken in 3 ways. Either take only one step, or take 2 steps, or take 3 steps. And then the remaining steps can be used into a recursive call. To find ways to climb the remaining steps. That's why you have this. Okay, now how do you find what will be the base cases for this? Also, how to determine base cases. So to determine the base cases, you can see that in this equation you have n minus 1, n minus 2, n minus 3. You need all of these numbers, all of these integers to be well defined, like to be well defined for any n, which is from n goes from 1 to 20. So let's say if I put 1 over here, these two numbers will give me negative values. 1 minus 2 will give me minus 1, 1 minus 3 will give me minus 2. So that means one should be a base case. One should be handled differently and not be calculated using this equation over here. Similarly, if you put n equals 2, you will see that this last number will go negative and this will go 0. Even 0 is not handled by our code. So n equals 2 will also be a base case. Then you try 3, 3 will go 0 over here. 0 is not handled by our code, so 3 will also be a base case. But any number from 4 onwards, from 4 onwards will be a valid call to pause phase. So this 4 minus 1 will give you 3, 4 minus 2 gives you 2, 4 minus 3 gives you 1. All of these are valid inputs to pause phase. So any number bigger than 4 will work, but all 1, 2, 3 will be the base cases. They will be handled differently and cannot be calculated using this recursive equation. Okay, so yeah, that's all. Base cases will be 1, 2, 3, and then the code is simple enough. Climbing steps. Alright, let me just add some comments. So these are base cases, and this is the recursive step. Oops. So let's see the base cases once. I just put this here. So for n equals 1, only one way of climbing. For n equals 2, we can have 1, 1 or 2. So 2 ways. For n equals 3, we can have 1, 2, 2, 1, 1, 1, 1 and 3. So a total of 4 ways. So yeah, that's the reason why this is 4, this is 2 and this is 1. These are the base cases, and then you just do climbing stairs n minus 1 plus climbing stairs n minus 2 plus climbing stairs n minus 3, and that gives you the answer for this. Yep, that was it for this question. Okay, now you have robbed the house. So there's a burglar who wants to rob houses and he wants to get the most amount of money, but he cannot rob adjacent houses. He cannot rob, if he robs house I, then he cannot rob houses I minus 1 and I plus 1. That's what this says. And you want to find the maximum amount of money you can rob without robbing adjacent houses. Okay, so let's see how to solve this. So one mistake that most students were doing is why is this so small? Simply summing odd and even elements and returning their max, which is wrong. This is a wrong way of solving it. The reason being that you can select odd and even numbers both. I'll show you right now. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Fine. Let's say that you select this number here and you cannot select this guy then. So it doesn't necessarily mean that you have to select this guy. You could choose to select this guy as well by leaving this person, and then you'll have to leave this person. So doing this, summing odd and even elements and returning the max of them is wrong, because you can have odd and even elements both together. To solve this correctly, you will require recursion. Okay, so let's look at how to solve it using recursion. So alright, so you have this array. I start from the back, so I start from here. So let's say that I decide that I want to rob this guy. If I want to rob this guy, then I cannot rob this, and then I'll be left with this array to decide what do I want to do with it. Right, this is one case. Let me move this up first. Okay, and then the other choice that I can do is to say, well, I don't want to rob this guy, I will leave this person out. If you decide this, then you have this whole thing, like you have all of these houses to decide which one you want to rob from. These are the two choices that the robber has, and the robber will pick the choice whichever gives him the most money. I pick the max of both the cases. Okay, so now you can see that, well, in this case, the thing that I've circled here, this is the same problem as this big problem, but on n minus 2 elements. So if there were n elements at first, you have gotten rid of 2 elements and you are solving the same problem for n minus 2 elements, right? And similarly, this here, you are solving the same problem for n minus 1 elements. You got rid of this last guy and you're solving the same question for n minus 1 elements, and this should give you the idea of using recursion to solve this question. So okay, this is the base case. So I'll skip the base case for now. Let's look at this part first. Okay, so you have nums I. So nums I plus rob house I minus 2 nums. Okay, wait, let me first explain the function. Why is this so small? Rob house takes an int I and a vector and nums. So excuse me, I is the index from which index at which you decide whether to rob or not, and nums is the array of all houses. Um, so in this case, this was I over here, and similarly over here this was I. Fine. So this is what I is, and nums is just this whole vector, or this whole array. Okay. So nums I plus rob house. This is money from this case would be this. So you select nums I. So you take the money that was in this house, and then you find how much money you'll get if you rob these I minus 2 houses, and you add it together. Similarly, money from this case would be simply this rob house I minus 1 nums, because you left this guy, so you didn't get any money. So you find how much money you'll get from the I minus 1 houses left, and yep, that's it. So now what you do is you just take the max from both the cases, and this is what is written over here. So you either choose to rob the current house and then find how much money you will get by leaving out the I minus 1 house, or you leave the ith house and find how much money you will get from the other I minus 1 houses. Okay, this is the recursive step. Now in our question, n starts from 1. So if you put n as 1 in any of these cases, you will see this will go to 0 and this will go to minus 1, and both of these are like invalid recursive calls. So this suggests you that you need a base case for I equals 1, or sorry, n equals 1, and then okay, so I goes from n 0 to n minus 1. I forgot to mention this. N goes from 1 to 30. Oops. And I goes from 0 to 29, because I is the index that I'm using. That's why I'm passing n minus 1 here. So let's consider 0 now. So if I is 0, this will give you minus 2, this will give you minus 1. Both of these are negative, so you need a base case for I equals 0. And similarly, you need a base case for I equals 1. For I equals 2 and onwards, these will give you valid recursive calls, so you don't need any more base cases. So you need 2 base cases for I equals 1, 0 and I equals 1. Okay. So when I is 0, which means you are at the last house, like you are at the first house over here. So whatever be the case, like whatever money you have, you will always choose to rob, because there's only one house left. So you don't have any other choice but to rob that particular house. That's why you just return nums I. If I is equal to 1, which means you have 2 houses. So you have this house and this house. So you can select the one which has the maximum money. You cannot rob both the houses together. So you select whichever has the maximum money in both of these houses. You select that. That's why I've done max of nums I and nums I minus 1. So yeah, those were the base cases, and then the recursive step I've explained. So Yeah, that was all for this question. Okay, now on to the fifth question. Catch me if you can. So this is similar to the last question that we had, Rob House. Um, the only difference is that over here you have a circular. The houses are arranged in a circle instead of a straight line. So, um, okay. You have a circle, like all the houses are arranged in a circle now. So let's say this was index 0 and this was index n minus 1. So now these two are neighbors as well. Um, in the last case, you didn't have these two guys to be neighbors, but now you do. So how do you solve this question? So one thing you should notice is that if you pick n minus 1, then you can no longer pick 0, and if you pick 0, then you can no longer pick n minus 1. Okay. And let's say if you remove n minus 1 entirely, then what you're left with is just the Rob House question from um, the last question basically. Now there is no circle. If you remove n minus 1, there is no circle anymore. This is a straight array. So you can solve this the same way as you had solved the last question. Okay. Similarly, if you remove 0, if you were to remove 0, then you will again have a straight array and you can solve it the same way that you had solved the last question. Okay, so if you solve these two cases independently and you take the maximum money that you can get from these two scores, then that will be your answer directly, because you cannot take both of these together. You cannot have 0 and n minus 1 taken together ever. So you just simply exclude n minus 1 in one of the case and then find the answer, and then you exclude 0 in one of the case and then find the answer, and you take the max of both of those answers, and that will be your final answer. So that is what I have done in the code as well. So this is the same as the last question. This function is the same. Only thing is now there is a start. So in this question I was using 0 and 1, but now I am having a start index. So if I is equal to start, then I return nums I, and if I is equal to start plus 1, then I do this, and you just pass start from over here. Okay. That's the only difference in this function here. Okay, now we come to the main function. We have this array nums, we take this as input. Now if n is 1, so if there is only one house, then you simply return nums of 0. This is not required. You can put this in an else. Yeah, okay. Alright, so 0 and n minus 1 cannot be taken together, so you solve both of these cases independently. So over here, this is going from 0 to n minus 2, and this goes from 0 to 1 to n minus 1. You solve both of these cases independently and you take the max of both of these cases, and that will give you the answer directly. So yeah, that was it for this question. Okay, now on to the sixth question, Aizen versus Ichigo. So this question is similar to the two-player game question that was there before. I don't know which question was it. The second question. So if you haven't seen that question, see that first, because the solution for this question builds up onto that. Okay, so you have this matrix, and in one move you can either select these numbers or you can select these numbers. You cannot select the diagonal numbers. The diagonals are not considered, so forget this. So you can either select this or this. And then for the second move, so let's say that you selected, oops, how do I use this? Let's say you selected the upper part. So now Aizen has played, so Ichigo will have the option of selecting either 3 or selecting this, right? And then since this is bigger than 3, so Ichigo will select this, and now Aizen has the option of selecting between 3 and 2. So Aizen will select 3 and then Ichigo will select 2. So the sum that Aizen will have will be this whole thing here. That is how you have to solve this question. So, okay, now to solve this, imagine that you have this guy and just rotate it this way for now. Okay, now see that if you somehow find the sum of this part, and sums of this and this, you will get something like you get a 1D array basically of, so this is 1 plus 1 plus 1, 3, 3 plus 3 plus 5, 8. So you'll have 8, then you'll have 2, then you'll have 3, and then you'll have 12 plus 5, 17. So you will get an array like this if you sum these up, and if you ignore the diagonal elements, you forget these for now. So you get this, and on top of this you can just apply the solution for a 2-player game to get the answer, get the score for Aizen. So here Aizen can select between 17 and 8, and then 3 and 2. So the score for Aizen will be 20 at the end, which is what the answer is in this example. Okay, so your solution will be in 2 steps. So forget this. So your solution will be in 2 steps. The first part will be to convert the 2D matrix into a 1D array of scores. You need to sum up the lower and upper parts and store them in a 1D array, and then after this simply apply the solution for 2-player game as was done before. So the 2-player game solution was explained before, so you can go and look at how to solve the 2-player game first. In this this part, I'm just going to explain how do you convert this 2D matrix into a 1D array. That is what I'm going to explain. Okay, fine. I will actually select this. Okay, fine. So how would you do this? Think in terms of recursion. We'll build an array for storing the lower sums and another array to store the upper sums, and we'll just join them, or rather append them together to get the full array. Okay, so over here you had this, right? So what I'm saying is you build two arrays. One will be this, which will be a lower, and the other will be 317. So you build these differently. Actually, this will be the other way around. So you'll have 17 first and then 3. So the upper is in the reverse order. The reason why upper is in the reverse order is because that is how the algorithm will go, and then the full array will be 8 to 317. And finally you will apply the solution for 2-player game on this full array. So now you need to calculate these lower and upper arrays correctly, and then you can join them together and then apply the solution for 2-player game on this full array, which contains the score for everything. Okay, so now to construct the lower and upper arrays, also explaining the reason for upper array to be reversed. Okay, so I'll just use this image again. So you have this. Okay, so the first step step 1 would be to make all diagonal elements 0. Okay, so you make all of these zeros, so you don't need them. Basically, just get rid of them entirely. These are all 0, 0, 0, 0. Right? I'll just write 0 instead. Oops. Good. Okay. This is 0. This is 0. This is 0. This is 0. Okay. After you've done this, you will step 2. Write a recursion to calculate upper and lower. So I'll show you the function so you get an idea. So this is the function calc upper lower. It has nums lower, upper and start. So I'll just write that down here. Okay, fine. So you see that lower and upper are passed by reference because they are updated and at each recursive step. Nums is passed by reference because it can be a big matrix. You don't want to waste memory in copying nums again and again. And here start is the index, or you could say index at which or from which you start recursing. Okay, so it's not actually the index, but I'll try to explain it. So in the first step, start will be 0. So when you start the recursion, start will be 0, and the first step you will calculate this sum and this sum. Okay, that is in the first step. So you will store in step 1 you calculate the outermost boundary sum of the array of the matrix and store it in upper and lower. So after the first step, upper will have 17 and lower will have 3 plus 5, 8. Okay, then you have gotten rid of this part of the matrix, like this part is gone. So now you are left with only this small part. So over here start will be equal to 1 for this, because first it was 0, now it is 1. Over here you will calculate the sum of this and this, and you will store that into your upper and lower. So at step 2, start equals 1 and upper will now become 17, 3 and lower will now become 8 and 2, which is what we needed over here exactly. This is what you have calculated. Okay. Alright, now you have gotten rid of this part as well. So now for the third part, start will be equal to 2. So, and there is no element left in the matrix. So at step 3, start equals to 2, and since start is equal to n by 2, where n is the size of the matrix, this forms the base case, and we simply return from here without further modifying lower and upper. Okay, so we just return from here because we have solved what we wanted. So start goes from 0 to n by 2, n by 2 included, and when start is n by 2, we simply return without modifying lower and upper. Yeah, so in each recursive step, what you do is you calculate the boundary sum, and then you just call the recursion on the inner part to update the lower and upper arrays. Okay, so yeah, this is one part. So now okay, so now let's look at how do you calculate this and this for the first step. So start gives you the starting index at which so I'll just show you the code instead of me explaining this. So this is the calc upper lower function. So calculates upper and lower vectors recursive. Okay, So yep, this is the base case that I said. Simply return further modifying upper or lower. Okay, then these store the so some upper and some lower stores this this and this, right? This is stored by some lower and this is stored by some upper, and they are then pushed back into upper and lower. So at the end of first step over here you will have some upper equals 17 and some lower equals 8. Okay, so now to find some upper and some lower, store start from and go up to n minus 1 minus start. So to understand this loop, it will be better to take the second case. So let's say that you have gotten rid of this part, so you are left with this inner part, and both of these are zeros. This is 0, this is 0. Okay, and right now your start is equal to 1. Okay, I'll get rid of, so start is equal to 1. Also notice that this index is 1 and this index is also 1. So yeah, that is something you should notice. Okay, so now what you do is start iterating from start to, so you have to start from 1 and go up to 2. You don't have to go to 4. So that's why you're doing 4 minus 1 minus 1, because you start from the start actually. So n minus 1 minus start. So you start from start and go to n minus 1 minus start to sum this part up and this part. Okay, let me tell you what the first for loop does. So it goes from start to n minus 1 minus start, and you do sum upper plus equals nums start I. So since start is 1, this is equivalent to saying 1i. So sum 1, okay, this this is, oops, this is nums 1, and this is nums n minus 1 minus 1, or start rather. Okay, fine. So I'll make this to start again. So sum upper sums up all the elements in nums start. So it will sum up 0 and 3, because this is 0. So you will sum up 0 and 3 and store it in sum upper, and sum lower will store I and start. So I is this. So okay, you are modifying the rows but keeping the column constant, so you will essentially sum these two up. So you will sum up 0 and 2 and store it in sum lower. That is what the first for loop does. In the upper part you store this, and in the lower part you store this. Now in the second for loop you will store this in the lower part and this in the upper part as well. So that is what is done in the second part. For some upper you keep the column constant, so you keep the column constant as this, and you modify the rows to sum up 3 and 0, and then for some lower you keep the row constant and you modify the columns to add up 2 and 0 and store it in some lower. Now you see that the corners are double counted. So when you summed this and this for some upper, you summed up 3 twice. Similarly, when you summed this and this for some lower, you summed 2 twice. So you need to subtract them once, and that is what is done here. So the corners are subtracted once to get the right sum. Okay, and then you simply add these sums to lower and upper, and then you recursively calculate upper and lower for the inner parts of num. Yep, so that is how you calculate upper and lower, and that is the reason why upper is inverted, like upper comes in the reverse order. Yeah, so then after you've done this, this is just a print function, you don't really need this, and you don't need this as well. Okay, fine. So in the main function you input the nums matrix and set all the diagonal elements to 0 to avoid them from messing up the sum calculation. Okay, that's why you've done sum I equal to 0 to get all the diagonals to be 0. Then you create two vectors which are empty, so they are empty vectors, upper and lower, and you call this calc upper lower. This function will populate the lower and upper sums and yeah, that's all. Yeah, after that you create a vector called full, and then you populate the full vector. Since upper was in a reverse order, you iterate it in the reverse order and then put elements in full. Okay, so since it was reverse, so you have to iterate in the reverse order as well. That's why you pop elements from the back in upper, but for lower you can just iterate it directly. You can just go in the same order and put things in full. And finally you call this function getScore. GetScore is the same function that was there for the two-player game question. So if you have understood this question, then this is the same thing. So you just call getScore onto the full vector and you'll get the answer for Aizen score. Yep, that was it for this question. Okay, so the next question is rotate the matrix. In this question you are given a matrix and you have to rotate it 90 degrees clockwise. Okay, so okay. So let's just take this matrix for example. So alright, let's say that this is uh, A of I comma j, where I and j are indices with which you are traversing this particular array. So currently, so for this like particular example, I is equal to 0 and j is equal to 2. Right, so you need to find um, the indices k and l such that a transpose k l is equal to 3, is equal to a I j. So essentially you want to find like where will this 3 be mapped, which is over here. So for this case, you'll have k equals 0 1 2 and l equals to um, 0 1 2 2. So there is this pattern that you might notice that the first row goes and becomes the last column. So whenever all I equal to 0 go to uh, L equals n minus 1. Just a second. Okay, so um, yeah, you can assume that the number of rows is R and the number of columns is C. So this over here will actually be R minus 1. Yeah. So this part is R and this part is C. So this part will become R and this part becomes C. So that's why you have all I equals 0 go to R minus 1. Similarly, all I equals 1, which means the first row will become the second last column. So this will go to L equals R minus 2. So in general, any I will give L equals R minus 1 minus I. Fine. And then similarly, you observe for all the columns. So j equals 0 here. Let's take this example. So you had j equals 2. Over here also k remains 2 as it is. And the first column remains in the first column itself. The second column remains in the the first column goes as the first row. So j equals 0 gives k equals 0. J equals 1 gives k equals 1. J equals 2 gives k equals 2. So in general, any j will give k equals j. So yeah, so if you want to calculate a transpose, the transpose, my bad, a rotated, let's just call it AR for now. So if you want to calculate AR,
So the formula for have the formula for any general AR would be A of R J comma uh, R minus 1 minus J I sorry will be A of IJ. So as you found L equals R minus 1 minus I here and K equals J, so you just substitute those over here and then you use this formula to calculate this rotated matrix, and that is what's done in the code. So function rotates the matrix 90 degrees clockwise and returns it, prints the matrix. So I've just written a print function here which just prints each number one by one in this particular order. So you have this take nums as input and then print the rotated matrix. So over here create AR and you fill AR according to the formula. And then you return it and then you print it over here. Yep, that's all for this question. Okay, now on to the 8th question, the Great Greek Treasury. So in this question, you have a sum and you have array of coins, and how you need to tell how many ways are there of making this sum using the coins. So the example they take is sum is 4 and coins is 1 2 3. Yeah, so there are 4 possibilities and you need to find out how to find the number of possibilities there are. So your function get what should I call it, what have I written, get money. So you'll have a function which will have wait, let me just follow this. Okay, we'll have this. So coins is just the array of coins passed by reference to optimize memory to save the copy operations. So that's why you just pass it by reference. You have sum which you want to fill up, which you want to find ways to fill up, and then you have I, which is the index from which you start, no, until which you take coins. So I'll just place it. I'll just make this small, I guess. put here this one. Fine. So you have coins 1, 2, 3, and you have sum equals 4, and at the start I will be I equals n minus 1. Okay, so n minus 1 in our case will just be 3 minus 1, so I will be equal to 2, because n is the size of the coins array. So I equals 2 means that I is pointing over here right now at 3. Alright, so now you have two choices, so to say. You can either pick a coin, pick a 3, and then find the number of ways to make sum minus 3, which will be 4 minus 3, which will be equal to 1. So you either pick the 3 and then you find how many ways there are to make a sum of 1 from the remaining coins, or what you can do is don't pick a 3 at all. Find the number of ways to make sum using the rest I minus 1 numbers. So find the sum 4, find the number of ways to make 4 to make sum actually using coins up to I minus 1, which just means 1 and 2. So you just use the first two numbers and find the number of ways of making sum. These are the two options that you have. So you either pick a 3 and then find the number of ways of creating 1, or you don't pick a 3 and then find the number of ways of making sum using the rest of the numbers that are there in the array. So your recursion would be something like get money coins sum I will be equal to get money coins sum minus coins I plus get money coins sum and then I minus 1. This is your recursive call. So one doubt that students usually have is, why is there I here, why not I minus 1? Like you've already selected a 3, right? So why is it that this is I still? So the reason why this is I and not I minus 1 is that you can have multiple 3s. So let's say that let's say sum was 6 and you had coins as 1, 2, 3. So you can have 3 twice, hence this is kept as I. So once you have picked a 3 coin, you can pick it again. That is why you have kept this as I minus 1, I and not I minus 1. But in this case, you have already chosen that you are not going to pick 3 anymore. Like you are just saying that I will not pick 3 again. So just find the number of ways that I can make this sum using the other I minus 1 coins. Okay, and you always start from the back, so you start from the last element. That is why you only need to go in one direction. You don't need to look at the previous elements and all this. So yeah, that's it in this question. There's not much, there's nothing else. Okay, so the base cases. So as you see here, like this part, uh, oops, this part of the recursion and this part of the recursion is where you will need base cases because they can give errors. So this is where the base cases handling is required. You can have I going, sorry, I and sum going negative, and thus you need to put base cases for this. Um, okay, so the first base case is simply that if sum is 0, then you return 1. So if the sum is 0, then there is always one way of selecting coins, which is nothing. Like you don't select any coin at all, you will get a sum of 0. Alright, if the sum is negative or if I goes to 0, so over here I have taken I as n and not n minus 1. So in this explanation I said that, what did I say? I took I as 2 over here, but in my code I've taken I as 3. So that's why I said that I can go negative over here. Okay, let me just make changes to match this. Coins I minus 1. Okay, yeah. So now the code is according to what I explained. Let me check if it works. Okay. Yep, I think it's fine. Alright, fine. So yeah, you have I as n minus 1 now. So if I goes negative or if sum goes negative, then in either case you return 0. This is not possible. Like this is not, you cannot make a negative sum or from like negative coins. So you return 0. Otherwise you just return the recursive call for both like both the recursion, like this equation. Um, yep, that was it for this question. And money heist. So money heist is a rather involved question. It requires some concepts that you haven't learned yet in your course. The You could try to solve it, but it will not be easy. So I will not burden you with solving this question. So I am not going to solve this question in the tutorial. So I'll just give you a general idea of how you can try to solve it, and then you can try it if you want to. So there are, okay. So you have like a matrix. Um, Okay, this is good enough. And you want to rob these places, like all these guys have some number in them, I guess. Yeah, they all have some number. So uh, this will have, let's say, 2, and then this will have 3, then this will have 1, this will have 5, something like this. Like all of these have numbers, and you need to find the maximum sum of numbers that you can get without stealing adjacent rooms. So let's say that if I loot this house, then I cannot lose the neighbors of 5, so I cannot loot all of these. Okay, and then I have to find the rest of the sum from here. Okay, so to solve this, firstly, uh, you will have to construct all possible. Okay, so let me start off with a mask. So first you have to construct a mask. So what a mask is a 2D Boolean matrix uh, where 1 means that you're gonna loot this house, and 0 means you're gonna skip it. Okay, so you're gonna create a Boolean array, a Boolean matrix where 1s represent that you're gonna loot it and 0 represent that you're gonna skip it. So an example would be, like, for this particular case, you could have I'll just move this guy over here and then move this over here. So let's say you wanna loot this house, so you'll put 1 here. So then this will become a 0, 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 this will become a 0. Okay, and then oops. Alright, and then you can steal this. So this becomes 0, this becomes 0, this becomes 0. I hope you get the idea. And then these will also be, like, placed accordingly depending on what numbers there are here. So this is a mask, like you have created a mask of 1s and 0s representing which houses are you're gonna steal, and you have to make sure that that each one is surrounded by zeros. All neighbors of 1s should be zeros. This is the condition given in the question. Okay, so now what you do is construct all valid masks and then find the sum of the matrix. So for each mask, so once you have made this mask, all you have to do is just multiply this number to this number. So you multiply 0 to 2, 1 to 3, 0 to 1, 1 to 5, and you do like a scalar multiplication, not a matrix multiplication. You do a like element to element multiplication, and you'll find the sum, like how much money you can steal using this particular mask. So you do this on all masks, and then at the end you just take the max sum possible, and that and that would be your answer. So creating these masks and creating all of them, like not missing out on any, it might be too advanced for you right now. So you can skip it for now. Yeah, so if you understood like how to solve it, I think that is more than enough. There is also a recursive way of solving it. So this like you can create these masks recursively or iteratively, anyone is fine. But yeah, that was the question, like that was how you had to solve this question. So yeah, that's it for lab 8. Okay.